Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Firstly, let me introduce myself. I am DIMAS KURNIAWAN and my student ID number is 18. In this occasion, I will present my talks about covering about journal review assignment. And next, here is the details of journal that I review. The first detail from the journal is implementasi Kalman filter pada sensor jarak berbasis ultrasound, and journal from jurnalistik, instrumentasi, dan elektronika terapan. And the volume and page from the journal is volume 2, number 2, page 20 to 24. And the year the journal published is in October 2021. And the author from the journal is Ervan Surya Astinugroho, Nerissa Diana Resti, and Imro'atul Hudati. And this is the abstract from the journal. In sensor readings, there will inevitably be noise that affect the reading result. This noise can be caused by various factors such as the device low specification, external signal interference, and the complexity of the measurement being performed. From the abstract, we know that Kalman filter algorithm was utilized for ultrasonic sensor use. Kalman filter estimates the proper measured values from ultrasonic sensor. The type of ultrasonic sensor used is HCSR04, which is capable to detect the distance range from 3 cm to 350 cm. The Kalman filter algorithm is implemented using the Atmega 32HB microcontroller on the Arduino Uno board. The algorithm is then tested with 5 different distances. The results show that Kalman filter algorithm is able to reduce ultrasonic sensor measurement noise. The analysis shows that the standard deviation significantly decreased, showed by the average of the standard deviation of the 5 tests decreasing from 0.3801 to 0.0173, or almost 95.05%. Next, the introduction. In this research, ultrasonic sensor is used to measure the distance on an object. The sensor has weakness since it is very sensitive toward the change and has noise from external factors. Thus, a method is needed to overcome the weakness. In this research, Kalman filter method will be used to overcome the weakness. The Kalman filter is reliable in the various aspects of application. It can estimate both the previous and the current data, even can predict the next data, and can make estimates in a system state where the module is unknown. In the next introduction about ultrasonic sensor, the ultrasonic sensor type HCSR04 is used as a sensor system to detect the distance. The sensor has two pins that serve as a transmitter and receiver. At the output, the sensor has 4 pins, namely VCC, trigger, echo, and ground. The sensor works by emitting ultrasonic wave through the transmitter and then reads the wave reflection using the receiver. The ultrasonic wave is emitted by the transmitter via pin trigger that is given the pulse signal by the microcontroller. Then the reflected wave received by the receiver is forwarded to the microcontroller via pin echo. From the concept, it can be seen that the ultrasonic wave is emitted when the sensor is given a pulse signal with a period of 10 microseconds via pin trigger. The ultrasonic wave emitted and reflected has a frequency of 40 kHz. The resulting lag time between the transmission and reflection wave is used as a reference to calculate the distance of the sensor to the object. And the next is introduction about Kalman filter. Kalman filter is an algorithm that can perform recursive estimation of the state of the dynamic behavior of a system. It is also able to estimate the state when models of dynamic systems are not well known. This Kalman filter algorithm formulation is designed in the form of discrete time to estimate the state and measurement of the dynamic model best as follows. And next is the method. This is the figure 1 is system block diagram. The device used in this research is Arduino Uno as a microcontroller, ultrasonic HCSR04 as a distance estimation sensor, and a laptop that functions for Arduino serial data communication, and as 5-volt power supply for Arduino using the USB-A port. Arduino power supply is used to supply the module. Next is the hardware implementation. The figure 2 shows the wiring diagram from the Arduino Uno and the module that used in this research. The ultrasonic sensor is connected to the microcontroller through Arduino pin 6 to receive pulse signal as the trigger for the sensor. It's also connected to pin 7 of the Arduino to transmit the measurement results, which are subsequently processed on the microcontroller. Additionally, it requires a power supply from the Arduino Uno to activate the sensor module. So the VCC pin from sensor is connected to 5-volt pin Arduino, and the ground pin sensor is connected to ground pin Arduino. Next, this is the result data equation. In this research, measurements were conducted with 5 different distance or target variations, ranging from 50 mm to 250 mm. Subsequently, each measurement involved the collection of 100 data points. In the figure 3 shows us the different data measurement from HCSR04 by using Kalman filter and without using Kalman filter. The blue line is measurement without Kalman filter, and the red line is measurement using Kalman filter. We can see that the red line is more stable, and the figure 4 shows the error comparison. Ultrasonic measurement without Kalman filter produce higher mean error. And the conclusion from this research, the Kalman filter algorithm has been successfully designed and tested for data acquisition in the HCSR04 ultrasonic sensor system. The test results indicate that the Kalman filter algorithm is capable of reducing noise in the measurement produced by the sensor. This is evidenced by the average mean square error values decreasing from 0.2198 to 0.0871 in all 5 tests, representing a reduction of approximately 60.8%. Okay, and that's all I can see. Thank you for the attention. Assalamualaikum warahmatullahi wabarakatuh.